Month 2 of developing a learning tool to learn Japanese by using NFC tags. I'm planning to get out of the prototype phase and start testing on real hardware and add a custom PCB. Goodbye forbidden spaghetti. For this test, I'm going to check how much distance I can have between the reader and the tag before I create my enclosure. I will be testing two sizes of NFC tags, 10 and 15 millimeters. As you can see here, I started by messing up by writing 25 instead of 10. There are two ways to go about it: reprint to change 25 to 15 or not care at all. At first I thought I could do like Bart Simpson and replace the 2 with the 1. I made a horrible job of it, and since I couldn't let it slide, I researched if there was a writing system in which 15 could be written as 25 to justify my mistake. As it turns out, in base 5, 15 can be written as 30, which is also 20 plus 5. It wouldn't make any sense at first glance to write it as 25, however. It would basically be saying 60-10 instead of 70. I remember that the French actually count like that, so it was no mistake but a lower setting happy accident. In the strict French translation, 15 will be now written 25. Back to the tests. I'm using the RC522, which is the most used reader for NFC tags on the maker's market. After reading the datasheet, which is my favorite kind of bedtime literature, I noticed that there was a register allowing me to change the gain to receive the tags better. For this test, I'm using the second to most powerful settings, so you could theoretically push it a little bit more. Before checking the results, I must say that I've read a lot of datasheets by now, and it's absolutely fascinating to see how much electronics is just changing numbers on registers. We are living in the crazy world of digital abstraction, which is based on electrified rocks changing register bytes. Back to the tests. For this test I'm using ASA plastic with 100% fill, but it doesn't really matter, as you'll see. From the get-go I could see that the 10mm tag was way weaker. Indeed, going from 10 to 15mm in diameter gives you 125% more surface, and it's definitely showing up here. The 10mm tag worked well up until 1cm distance and needed to be placed perfectly in the center. The 15mm tag gave reliable results up until 20mm. At the end, interestingly, both tags have approximately the same read distance of 10 and 20mm with nothing but air between the tag and the reader. As far as my project goes, I decided to continue with the more robust and reliable 15mm tag. Good thing I bought 250 10mm tags for this project. Have you seen the blinking LED? Tell me in the comments why you think I set it up this way. Answer in next week's video. Bye.